let's start. Please keep silence. I have pleasure to introduce you Pavel Jolkin from SEB. Actually, the same bank I worked for 21 years, sometimes ago. But we have never been working together with Pavel, so we actually have not been colleagues. I don't introduce Pavel more because he has prepared the slides. Pavel, the questions, can they have questions in the...
Yes, regarding the questions, I would ask you, and actually, as a matter of fact, I will encourage you to keep this lecture as a dialogue. Please don't wait for the end of the lecture to raise a hand and ask a question. Actually, don't need to raise a hand at all. Please just shoot the question. Just wait for the logical point for me to stop and shoot. Matter of fact, this will be one part of the lecture will be a conversation, interactive part where I will be asking for your input. We'll try to put the puzzle together. All right?
And please keep in mind that in this classroom, the recording voice is from everywhere. So your questions, your remarks, and even your shoutings will be recorded automatically. There is no way not to do this. Okay, please, floor is yours.
Thank you. Well, I will speak a little bit about myself. Thank you for such a wonderful introduction. My name is Pavel, and I've been in IT for over 20 years. I started back in the days working in the United States for the telecom companies. Different roles, different positions, different things I was doing, but everything from the telecom technician to the IT department manager, mostly for the telecom companies in the United States. And here, when I returned back to Estonia, mostly I was working for the larger corporate level the IT companies. So Symantec is one of the companies on my list, Ericsson, and currently SEB. SEB is my current employer at the moment, and as Pavel mentioned, we didn't cross at SEB. I got onboarded and hired a little bit later on. But nevertheless, spent quite a lot of time in a field of, and have I want to say, the interest for agility and agile development and things of that nature. So we will be speaking quite a lot today about the frameworks and software development, how the things fit or how they don't fit, and where the agile, which is probably one of the overused words in our days, where it's acceptable, where it's not, where it's applicable, where it's not, where it's just a buzzword, really. So we'll stop on that. Again, different roles in that area. I've been a Scrum Master, I've been the Product Owner, I've been the Chief Scrum Master, I've been the Agile Coach, I did all that good stuff. But nevertheless, I was never losing my kind of the technical side either. Meaning that during all that time, my attention was kind of pointed towards how to help the teams from the engineering perspective, from the technical perspective. What else can be done? So I didn't kind of go away from the technical world and kind of kept a grip on the technical side as well. Quite recently at SEB I took a more technical position, and currently I am in the area of so-called non-functional requirements. I'm an architect, and probably the best way to describe my role will be the performance engineer, the engineer who takes care of operation of the performance, operation of the system, its performance, its non-functional part. It's not about how system operates, it's about how well it operates. Yeah? And we will be talking about that quite a lot today. So that's about me. Unless any questions so far, I will move on. So today we will talk about several things. If I understand correctly, this audience might be not so interested in tools, specific tools used for the performance testing. I will just quickly go through that part, just give you some big names on the market, and we will move on. Today we will be mostly focusing on the roles in the larger organizations, who is involved in ensuring that the system performs well and performs to the expectations. Who are key people? What are the challenges? How does it fit into the frameworks? Things of that nature. I hope that will be interesting. And again, if we see that some of the topics, no, they are not resonating, they are not kind of your interest, just let me know. I have plenty of material. We can switch the topic. Yeah. So yeah, that's pretty much our plan for today. Also, we will have one semi-interactive exercise as well, where we will try to put the puzzle together. Hopefully that will wake you up a little bit and keep you active. Yeah? Okay, so agreement in place. No need to wait till the end of the lecture. No need to raise a hand. Please just shoot the question. Yeah? Good. Have you noticed that lately the life somehow speed up? Everything happens so quickly. Everything happens so rapidly. And I'm not talking about only the software. I'm speaking about every aspect of the life. We became impatient. What that means in a world of the software development? No, first of all, it dictates the higher demand for the higher performing software, and the software which is reliable and the software which is available way more when it was, let's say, tolerated previously. Now, just to give you several examples here, just over the last decade, we are experiencing the situation that if we're not getting the response of the website in, let's say 2 seconds, you close that website and you never come back there. That's the end of the story. And if we're talking about applications on the mobile, it doesn't operate for you quick enough. What do you do? 1 star, end of the deal, right? That's the new reality. The demand dictates the need for higher availability, more reliable, and more higher performing software. From the other side, to mention the downtime costs, and actually that's quite interesting topic because we just had single-digit, how do you call it, single-digit sale, or 11/11. Yeah? The sale which is going on, the crazy deals, everything you can get for cheap. And
Black Friday.
Black Friday.
They call it all the time.
Well, okay, you got the idea. Yeah, that one. What do you think happens during those times? If you look at the merchant, if you look at the information system, they are experiencing incredibly high load of the customers, which never been seen through the year. Correct? All of a sudden, the load on their system quadruples, probably, if not more than that. And how do you think
and the losses are huge. I mean, if you're unable to serve the customers who are willing to pay for the goods, what's going to happen? They're going to go somewhere else. So the losses, you can see the case in the middle there, the losses just skyrocketed. Not a whole lot of companies can afford that. I mean, if you want to stay in the business, you need to provide the reliable software, which is available when customers are ready to make a purchase. Another thing which is quite relevant for our industry as well, here I have to put the little asterisk sign and say that, hey, look, only portion of bank services is considered a critical service. Not all of them. Some of them are. And we are quite, we do have quite hard rules and quite significant regulations on the uptime. And as you can see, now we are in second digit after the comma. It is expected to be at 99.99% available. Considering all that, we need to think, how do we design the software from the beginning to comply with those strict rules and the strict, I want to say, heavy demand from the market? Well, let's talk details about that. So, regarding the performance, I want to say in this slide I use the word tests, but I don't like it in this context. I probably would say performance evaluation. So, first of all, let's talk about what we mean by the performance in here. If you Google it up, you will find the different definitions, and different people define it in a slightly different manner, and the terminology is somewhere overlapping. So let's start from the definition. Obviously, this is something in the area of non-functional, right? This is about how well, how good, how reliable the software operates. Yeah. So we're speaking about several major factors here. We're evaluating the speed of the response. We're evaluating the stability under different conditions. Your classical performance evaluation is the umbrella of quite a variety of different tests, I want to say. Some of them are related to the system durability. Some of them are related to the ability of the system to recover from the let's say during the Black Friday, we experienced a situation where the load was so heavy that system couldn't handle it anymore. The denial of service happened. How the system recovered? Did somebody get stuck in the middle of the transaction? Things of that nature. Yeah? So we use the word performance evaluation as an umbrella term for all those things. Here, it is a table which compares the functional part of this software evaluation versus, again, I want to say performance evaluation, not performance testing. This term doesn't. No, I don't like it. Performance evaluation. Let's call it this way. Now, as we see here. We have different definitions, different goals, different focus areas, different tools are used, and the most important part, which we will be coming back today, the whole evening we will be coming back to that topic, is when to use, when it's happening. Yeah.
If we're speaking about the functional evaluation, I'm sure you all heard the phrase, as early in the development cycle as you can possibly do that, right? We want to find the critical bugs in the software as early as we can potentially do that. Why? Well, the answer is quite simple. The cost of the fix. Earlier you found it, less you need to worry about how it will be fixed, and the cost will be simply lower, and the impact. Yeah. Regarding the non-functional and the performance evaluation, we'll get to it, but you simply won't be able to do it in the early stages due to the nature of that evaluation. Yeah. Another thing which I would like to focus and stress the attention here is the focus area. The focus area for the functional tests, we will be talking about the user functionality and the behavior. And in the performance tests, in the performance evaluation, we are normally speaking about such terms as response times, throughput, and resource usage or resource utilization. If your classical evaluation in the functional part would look like you have a scenario, and well, it's either yes, the software operates properly in this scenario. When it comes down to the non-functional part, you will have slightly different looking record. The record will always look like you have the condition, under which condition the software performs in which way. And always you will have the range of the numbers. Now, your most classical example will be with a load of 100 users, the response time will be within this range of 0.4 milliseconds to 0.6 milliseconds, something like this. So that's the major differences. And here we'll try to work a little bit together and try to think about the factors which will affect the application performance. Let's try to imagine that, which example you like? Do you like the example of the eShop? Let's think about the eShop. What kind of factors will affect the performance of the system as a whole?
The amount of traffic.
Load.
Yeah.
Good.
In context of an e-shop, perhaps how many products will be shown to the customer at once?
Okay. I will take it as how loaded our databases are. How many records do we store? Is that what you meant? Or that's
Yeah.
okay.
Yeah.
Okay. Good.
Can it be code as well? Coding?
Efficiency of the code. Of course it can. Yes, sure.
Maybe dependency on like third-party providers.
Absolutely. Let's imagine you are authenticating yourself with a smart ID, and the smart ID is laying down. What do you do then?
Try again.
Try again. Might take the customer away from you. You might consider the alternative options. Okay, yeah, sure. You own the system.
Hardware of our display.
Absolutely. Yes, hardware, definitely. Let's talk a little bit more details here. What in the hardware world we are depending on?
Operating system.
as well. To a certain
Okay,
extent.
it's already software, but it's on top of the hardware, right?
Yeah. Network.
Yeah, routers,
Absolutely.
throughput, network throughput.
Network segment.
Yeah, and network routing and backup single point of failures and
Let's try to imagine we're working with a sensitive information. What else?
security protocols.
Data? Encryption? If we're encrypting any of our data? I've heard a comment from the back there regarding the quality of the code. Elaborate a little bit on that topic. What do you mean by the quality of the code? How well or how poorly it's designed, or memory leaks?
How efficient?
Efficiency of the code, memory leaks, design in general.
Validations in the code.
Validations in the code. You mean, oh, okay, yeah, hopefully they don't get all the way to the production. But, yeah, got the idea. You named most of them. I'm quite impressed. Security measures, environment, which we called it slightly in a different way. In here, the database performance is taken as a separate point. But again, the thing is that not always, not each e-shop, and I'm pretty sure that most of the e-shops are not running the software on their hardware which they own. What is the current situation in the business? Meaning, most likely you're going to be hosting your software somewhere on Amazon, Google, something of that nature. As soon as you get into the world where you, for some reason, obligated to run the software, or you chose to run the software on your own hardware, which you own, maintain, and purchase, take care of the licenses, reviewing the licensing models, and all that good stuff, you just multiply the number of those factors with a factor 5. Yeah? Most, I want to say, most of the performance-related software, performance-related troubles are laying in the surface of the hardware and the communication with the hardware. If you manage somehow to pass that headache to somebody else for the price, of course, no, you just minimize the amount of your own headache. But in certain areas, and bank is one of them, we are simply obligated to run certain parts of our applications on our hardware, on the hardware which we own. Okay, so that was quite clear. Good. I'm quite impressed. Thank you. Speaking about the benefits, what kind of benefits the performance evaluation will give you? Well, first of all, I want to say that in our world, as we started this conversation, as we started this lecture today, no, it is pretty much the must. You will be simply out of business if you are not interested in doing the performance evaluations. Now, of course, happier customers, improved user experience, things of that nature. Of course, you will have that. Cost efficiency. Now, that's where I would like to stop a little bit, talk a little bit more about that. Let's try to imagine the modern world where most of the applications are running on somebody's hardware. How does it work? And let's try to imagine the situation of Black Friday, which happened not so long ago. Okay, so normally you have some sort of plan, right? You're purchasing computing power from Amazon or from Google or from somebody. It comes with a plan. Okay, so through the year you are paying for this amount of computing power, and all of a sudden your load quadruples. What happens then? You are either out of your plan, and depending how the set your agreement with the hosting with the hardware provider is, you might get into the tricky situation. And that's where I would like to introduce the concept and give you the idea. Is a denial of service always that bad? No. If you are providing critical service and you simply cannot afford to have your main services down, that's one thing. If we're talking from the business perspective, the denial of service, know how bad it is. Somebody will not be able to, purchase something. Okay. Reputational cost, yeah. Also the losses in revenue. I get it. Let's take a look at the other side. Amazon charges you through the year X amount of money for the plan. The load all of a sudden goes ballistic. With the certain plans, they will say, okay, fine, we got you covered, not a problem. We'll spin up another port for you, not a big deal. But we will charge you, and we will charge you with a penalty, and we will charge you arm and a leg for that. More load? Not a problem. Here comes another port. You will run yourself out of money. Those out of service plan charges, no, they are quite ridiculous, I want to say, at least nowadays. And you really need to balance out between where it would be logical to pay that fee for additional computing power and where you need to simply say, that's it, this is enough. I'm given the denial of service. If it's not critical service, too bad. For me, as a company, it will be more financially feasible to give denial of service. Think about it. Denial of service is not a horrible thing. At one point, you need to give up if you're not the critical service provider.
So, do I understand correctly that you have this plan, and now you have this extra load, and this SLA is so badly formed? So, from the customer side, so I as provider, this e-shop, from my side, it's so not lucrative to buy that.
Absolutely.
But if I can negotiate better plan for this CPU increasing, then it's okay. It's just depending on the price only.
Of course, it's definitely depending on the price, depending on how well you negotiated your contract. But remember the old times when we had the plans with the cell phone on the minutes. Yeah, you have the X amount of minutes. As soon as you go over that amount, you will be charged armed and a leg for that. No, it's kind of the same concept right now is going on in the business of cloud computing. Or, I want to say, very similar situation. I'm pretty sure that it will average out the same thing as we experienced the situation with the cell phone. We don't have that problems anymore when we're getting charged ridiculous amount of money for going over the minutes, right? So it will average out, it will wash out at the end, but currently it is a situation. And the situation is like this.
But the quality when you go over the plan is the same as it was in the plan, that as customers I don't feel anything, I get the same
No.
speed and
No.
just the
No.
e-shop owner will pay for it. Okay.
Yes,
Okay.
you will just end up with a bill, with a heavy bill. You will feel the pain then.
But if as an e-shop owner, let's say I have some forecasting tool and I will know that, okay, in this month there will be like a week of very high traffic, then is it possible to like somehow beforehand?
Negotiate you the deal?
Yeah.
I'm not too good in SLA and SLO negotiations. I know that there is certain ways to deal with the situation. Why I brought up this example, I just wanted to get the understanding and get that idea through that denial of service is not a horrible thing. It's not the end of the world. You need to think about that when you design in your software, when you planning the amount of users which will be consuming your service, things of that nature. This is just one thing to consider. Then it's not that horrible. Yeah. I would like to summarize some of the things we just discussed and kind of put them as a bullet points, simply due to the fact that we will be coming back to that and referring all the time through the evening to those. Yeah. So, what those performance evaluation? How to characterize that? No. First of all, I want to say it is expensive exercise. Comparing to the functional tests, the overall performance evaluation on the system is very expensive exercise. Especially when you are talking about the system-wide performance test. No? Also, we have identified that we are sensitive to the hosting environment and the environment settings. We will need that understanding and keep that in mind today through the lecture when we will be trying to fit into the different frameworks. So we are sensitive to the environment. Of course, we are sensitive to applied load and load patterns. And another thing to mention here, and that's what we will use, and we will refer back to it when we will be speaking about fitting the performance evaluation into standard agile framework. Now, try to think about the thing which is called, again, different terminology, soak test, so-called, or endurance test. That's when you are trying to track down the memory leaks. The memory leaks normally don't happen immediately. You need a little bit of time to understand how the system operates. Yeah? Sometimes it takes months to track it down, to get the input and understand how the system scales up. That's why it's called the soak test. You put the system to work under, let's say, normal conditions for the period of time, and you see how it releases the resources, how it, let's say, how it utilizes the hardware in the most optimal way or not. Do you have any memory leaks or not? It takes a little bit of time just to monitor the system. I'm not even speaking about the results and making a hypothesis. I'm speaking about the monitoring part. Okay, so those tests, sometimes they require the extended amount of time. Okay. So now, let's speak about agile and try to fit the things in. Yeah, I'm certain all of you've seen that picture. Huh? The agile approach versus the waterfall approach. No, of course. Now, if we're speaking about simple system, well, let's say the mobile app, and one team of developers developing it, well, quite classical scenario. You get your classical agile cycle. You start from requirements, you go to design, you develop, you test, you deploy, and you review and launch. Seems to be quite okay so far, yeah? If we're speaking about the small system. And if we're speaking about some sort of very module-oriented performance evaluation, that fits quite well into here. If you are talking about on one module, let's imagine you are testing one API. Your team is responsible for the performance of one API. You mock the input, you do your magic, you test the throughput, you understand what's on the outcome of that. Within one team, fits into here so far. Becomes a larger problem when, let's say, when we're dealing with a huge system consisting of dozens of those cycles. What do you do then? How does it fit? Again, there's placement right here of the test. It's before it's even deployed. How's that? But we just determined that we are environment sensitive. How can we test something what we didn't deploy to the environment similar to the production environment and be sure about the results? Problem, huh? And it is a problem. So, again, the need for the separation of the performance evaluation of the system, separation it into the, I call it micro level and macro level. When we're speaking about the whole system and the evaluation of the whole system, how the whole system works as a whole, that's one set of problems and one set of kind of guidelines how to deal with that. If we're speaking about one module which is developed by one team, we can fit it into the classical agile cycle. Well, more or less. We will be making some approximations. Of course, we will not be testing on the environment which is production-like. We will be mocking or faking quite a lot of information. But we will be able to make a judgment how performance today compares to the performance a couple builds ago. Are we experiencing any major degradation? Did we do something what made our small part performance degraded quite significantly? We'll be able to make that type of judgment. System as a whole, still the problem. That framework definitely not resolves that problem. Okay. Actually, I will tell you the funny story about this multiple teams here. Each one of them represents that cycle. The things are going on there, yeah, and each one of them says agile in it. No, actually, it's if you're working for the corporate environment, that's what you will hear quite often. That that team, they have their own version of agile. Yeah. So I decided to do it like this. Now we have multiple teams developing each module, the system as a whole needs to have all those modules in. Well, performance engineer takes a look at the situation, has discussions with the architects of the specific modules, and all together they come to the decision that yes, we can make some approximations here. Yeah, we don't really need those two modules. Of course, they do contribute to the whole system, but we will take some approximations. We will cut them off with the chain and link, simply due to the fact to simplify our emulation to make it easier. So those we need to work together. So my cell phone, something else blinking. No, not even sounds. Okay. So we figured out that we need those five. But now we need to understand that they might be on the different levels of the development. Let's imagine this team might not be done when this one is. And again, we need to put them all into the hosting environment in order to evaluate the system as a whole. Remember, if we're working on the level of one of those cycles, we can mock the data coming in and do our measurement points in here on the exiting point and kind of compare it to the previous run. In here, we want to have an understanding how this the whole system operates. So we need to bring it to the environment. We need to bring it to the environment which is close enough to the production. And we need to do the tweaking and settings of the hardware to get the optimal results. And then we can make our measurements. So obviously that doesn't work. All right. So we need a different system. We need a different framework to support that type of activity. And remember, in the beginning, we said that it's crucial, it's needed. Without that, no, you won't be able really to survive in the modern world. So what do? Actually, a matter of fact, I'll speak about that as well. Absolutely classical layout. Software development cycle. I'm positive you've seen it. Yes, cool. All right. So, in here we do have a little bit of the problem as well. Where do we fit our evaluations? Here? Where it says testing? No. Not really, because we need the components to be deployed at least to some sort of test environment which is at least similar to the production. So obviously not here. Well, maybe in here we do the planning of our emulations and do the actual execution out here. Could be. Could be. But what I would like to stress your attention on, feasibility study. This is absolutely crucial for any kind of the performance evaluations. This is where business people sit down and get the understanding how their service, which we are designing and planning, will be used. What is the amount of users, what we are expecting, what kind of load they will put in the system. It's all should happen here. How often do we have it? Not yet. So further down the road, we need to guess. And we need to kind of squeeze that information out to the business. Architectural design. This is quite important part as well. When we are designing the system, we want to understand on what type of hardware we will run, what type of protocols we will use, how the pieces are going to communicate together, are we using any kind of databases, what are our connection types, things of that nature. So quite a lot of technical questions are getting answered right here. In here, we do keep the performance evaluations in mind. This is where this small cycle happens. When the team does a performance evaluation within one module, mock-in the information coming in, put in the load, and measuring what's coming out. So, classical, absolutely classical picture, absolutely classical layout, and you try to fit it in here and stick it in somewhere here, and it just doesn't go logically. Alright, so it has to be the answer somewhere, no? Obviously. If classics doesn't work, what do we do? No? Apparently SAFE system has some sort of answer to that question. Familiar with SAFE? Scale Agile Framework, Enterprise. Please heard that word? No? Good. So what it does? Now it introduces another level of governance above the governance of the software development in the single teams and a single component. It adds another layer on top, on the system level. Quite often we use in the enterprises and in the larger companies, that's absolute must. If you need to look at the system as a whole, you need to come up one level, and you need the set of procedures and rules and activities on the level above. Okay. SAFE is quite often represented, I'll go one slide back, quite often represented as two cycles, one smaller cycle, which is happening on the team level or the module level, and one larger one, which happens on the organizational level, on the level of the whole system, where the problems related to the system as a whole and the combination of those small cycles are getting taken care of. Okay, so what I can say, there is, at least I haven't seen so far, any perfect framework which would support the overall larger scale performance evaluation activities. SAFE probably is the closest one. All right. Now, let's talk about principles and the business cases where we might encounter the need for the software evaluation. I specifically separated them in kind of different sides here. This is column on the right, there is on the left, and certain in the middle, which overlap. So the idea behind this exercise or this demonstration is to go through the most common cases where the performance evaluation will be beneficial or even expected. The cases on your right, you most likely will be dealing with quite a lot of legacy. Something already exists. What I've heard from the engineers come into the field. Well, we don't want to work for the corporate world simply because you never will be working with the new stuff, you're never going to be designing anything new from the scratch, and I want to use new cool technologies. I spent X amount of years studying for that. My fingers are itching to implement this and implement that. And all that breaks against the brutal reality that most likely, in most of the cases, you will be working with a legacy. And you will be thinking about how to put together systems which already exist. Unlikely, you will be working from the blank list, from scratch. And this is something what you need to get yourself prepared, and you need to get the understanding of that. It's simply kind of the reality versus the expectations in some of the cases. But really, you will start your development is planning and designing of the software from the scratch only in case of the completely new development. But, okay, completely new development, company which will utilize the new technologies and everything, what characterizes that type of companies? What normally are they?
Startup.
Yes, startups. What is the main characteristics of the startups? From the employee perspective.
And more like innovation, I would say.
Innovative, yeah, absolutely.
Work hard, play hard. and then high risk and then high revenue.
High risk, absolutely. Yes, high revenue might be. Yeah, if you will see any, that's good. But yes, they are high risk. And well, actually, we're living in a time when we see where quite a lot of IT startups went, right? Do you remember the job ads and those lists of the job ads, I want to say just 2 years ago? And how do they look now? Something to think about. Startups will get hit first. So, maybe legacy is not that bad. At least from the point of view of the quite normal, regular employee. When do we see the need for this performance evaluations? What kind of business scenarios we might recognize? The most popular one will be business expansion. Yeah, we are coming up with the new features. We are acquiring the new market. And you say, well, hold on, we will just build everything new, right? No. You will be building on top of what the company already has. Most likely, you will be asked to incorporate the new feature or the new product into the already existing service. That's most common scenario. Mergers and acquisitions, quite popular as well. Who's a customer of Elisa? Well, they have two large sets of the client bases. I think after they purchased the STB, years ago, they still didn't merge it. They still have two separate kind of systems, and when you enter in the self-service portal, you have to click what type of customer you are. Are you old STB customer or are you new customer? What? So those mergers might be quite tricky. All right. So we discussed that. Now, what else to mention in here to highlight? Modernizations of the system. Oh, great work. It looks the modernization part of that looks quite promising. So what normally it means? That means that the technology which was originally used for providing of that service is simply not supporting the need and demand. And something else, newer, better, needs to be implemented there. At the same time, you will need to work with the pieces which are already in place. So pretty much, think how to modernize the puzzle of older software components, modernize them in a way not to destroy what is already in place, and make it work quicker, better, faster, and up to the expectation. Probably that would be the most, the hardest thing to do, and it requires a lot of skills. The ones which I placed in the middle here, the ones operational efficiency improvements. Why did I place it in the middle? Simply because normally those are the business cases when business is willing to optimize the already existing services, meaning that the service exists, it brings the revenue, it just simply needs to be brought up either to comply with certain regulations, as it quite often needs to happen, or let's imagine that we are expecting the huge expansion of the business, and we want our system to be prepared for that. I want to say this one is quite probably the most interesting business case requiring the performance evaluation out of all of those. That's most likely where you will have your hands untied, and you will be able to improvise, and let's say you will be allowed to do way more than in any of those. Okay. So, as we understand that, and again, I'm speaking about the large corporates. I'm not talking about the startups, small companies, the little moms and dads, little shops here. I'm speaking about the corporate level company. We will go through a little exercise. So we need to do the performance evaluation and think about your standard enterprise. What kind of roles, what kind of people will we need in order to build the team, to bring the team together, to test the system as a whole? We're speaking about not the small circle, we're speaking about that higher level. Let's think together. What kind of people do we need?
Specialists
Specialists, what kind?
in programming, in human resources as well.
No, human resources, let's leave them out of the brackets. Let's imagine we have the staff. We already have the people which are needed. We already have them in-house. We're not planning to hire anybody. Okay, so human resources, out.
Hardware guy? Hardware.
Hardware people,
Yeah,
yes,
hardware.
absolutely. Hardware engineer. What does it come close with? Hardware people, no, those admins who are sitting in the dark, yeah, monitoring the performance of the hardware. In our days, I want to say admins and people who do the monitoring in the larger corporations, that's two different profiles. So I would like to say hardware people who will tweak the hardware settings on the fly, and monitoring people who will be able to quickly monitor how that tweak helped or it didn't help, or it made the situation worse.
And different monitors for hardware and network traffic.
Okay, well, we call them network people. Yeah, they're a special kind nowadays as well. But let's call them all hardware people.
Okay.
Yeah? Okay. Those people, absolutely, yes, we need them. They're in
Security.
security.
Yes, and those testers.
Testers. Okay. Testers. How are we going to utilize testers?
While we are developing something, they can test, and also like these security testers who will check that there is a low possibility of
Intrusion?
information leaking.
Uh-huh.
Our own intruders, white hat intruders.
Yes.
Okay, you got into the security area. Could be, but probably they're not the main there. Again, you are getting a little bit in the area of functional testers. Developers will develop something, testers will test something. And not exactly how it works with the performance evaluation. We're dumping tons and tons of load, emulated load. Obviously, we're not hiring, if we want to evaluate how the system will perform under the load of 200 users, are we hiring 200 users to log in? No. Okay.
Some business analysts who can think the worst case business scenario of the Black Friday and then school holidays and everything applied together.
Business, yeah. Business people, absolutely. Let's call them business people. In the corporate environment world, currently they are normally called the product owners. But yeah, you got it right. People who know the cycles of the software and understand the load and how it will be distributed. Yeah, we absolutely need those. Remember when we've been looking at the software development cycle, I pointed out feasibility study. Yeah? So, generally speaking, during the feasibility study, we should have at that point the understanding of what kind of users, what kind of patterns, and what kind of load we're expecting towards the system should have been established. Yeah, that understanding. Of course, time brings the corrections, situation changes, yada yada. I understand that, but some sort of core understanding, at least say, would be, I know, hundreds per second or thousands per second or what we're talking about. Okay? Business. Good. Who else?
Software engineers.
Software engineers. What they will do for us?
They built the system, so they must.
Yeah, they did. But who knows the best how the system was built?
Software architect.
Yes. Software architect who understands how the specific module is built, how does it communicate to the rest of the modules, what is the overall architecture. Yeah, absolutely. And we need one from each modules which we will be working with, which we identified as a critical. Remember the picture with the red line, where we identified that those systems are critical for us for for us to evaluate, and a couple others, well, we decided that we simply neglected. Okay, great. Who's going to orchestrate all that?
Project management.
Yeah, maybe. If the project is really huge, project manager. The other option is the performance engineer. Important thing to mention here. As we already discussed, to emulate 200 users and how much load 200 users put in the system, absolutely we're not going to ask 200 users to log in and see what's going to happen. No, absolutely not. We're going to write the scripts which are emulating the behavior of 200 users. And whose brains I'm going to be picking when I'm asking how your normal user is behaving? The user logs in, what he does next. Looks at his balance, goes here, then he goes to his basket, adds stuff, checks out, how he normally checks out, how he identifies himself, how much time he spends here, how much time he spends there. No, I will be asking all those questions from the business people, who normally should have an answer to that. They never do, but they should. Okay, right? Pretty much we described them all. We got the solution, I want to say not architects from the different areas. We have the performance engineer who's going to either write the scripts or find somebody who will write the scripts, coordinate that activity. We need hardware people, and we need business people. Absolutely. We named them all. Great. Now, let's speak about a classical example of challenges when you're creating the emulation. No? Business. Let's not call him the product owner, let's call him business people. They have very shallow understanding of the use cases. Normally, the situation which, I've seen quite a lot of times in the different companies, that the design took so long that from the feasibility study, people simply changed. People who did the feasibility study, they already do. They're not with the company anymore. Well, they got some documentation, but documentation is shallow. You don't have a great understanding of the business case. You don't have the forecasted amount of users, their behavioral patterns, what they're going to do, how they are expected to utilize the system, and things of that nature. Also, speaking about behavioral cycles, from the bank I can say that we're experiencing the heavier load during the hours in the morning, then let's say towards the lunchtime it decreases, and there's some activity going on later on in the evening. And that goes on and on and on. No, it's you don't have to be genius to guess that during the beginning, the first month of the week, normally when people get paid, we're experiencing the heavier load. It's quite easy to guess. Also, the way larger cycle, when the tax time comes. On a yearly basis, one specific module experiences the heavier load. Those behavioral cycles, they could be obvious, like with the taxes and like with the beginning of the month when people are getting paid. They could be not exactly very obvious. And you need to monitor the existing system if you have something to compare with. Normally, if I hear from the business that I'm trying to understand what would be the forecasted amount of users utilizing the services of the system. And the first time I normally hear is, but hold on, you don't understand. No. You probably didn't read the request properly. This is a new service. How do I know how many users I will have? It's you who doesn't understand. The forecasted amount of users. If you don't know exact number of, I'm not asking you the exact number. I'm asking you the range. I'm asking you some sort of number to start working with. Okay, but how do I guess that? How do I forecast that? Well, I hope that that's how you build the business case, right? You obviously inputted some amount of users to calculate the revenue or potential revenue. If not, try to compare it with the other systems. Is that like this one, or maybe this one, or you expect it to be slightly higher than this, which we can monitor? Maybe that could help. So normally that's where you start. As a performance engineer, you start working with the business, try to understand the range. Okay. So that's the main challenge. Try to understand what kind of numbers you're working with. And another thing, what I normally hear, some sort of destructive mindset. You test that system and you tell me the number when it breaks. What you going to need that for? How you going to use that information? Why would you want to test your system against some sort of load which, no, okay, let's say this. We are Baltics Bank. Yeah? Will it be logical to test our system against the number of users higher than the population of the Baltic states? No, probably not. And this is considering that not every person in Baltics is SEB user, plus we have kids. Yeah? So you can already somehow do some sort of approximations and some sort of calculation on the numbers. So that's quite challenging part to get into the brains of the business person, that the number where the system will give denial of service, will quit operating, is not that important. It's way more important to evaluate around the real numbers, around the numbers which we will have on a daily basis, the ones which we'll have on the times of the increased load and those kind of things. So when we're speaking about solution architect, well, shallow understanding of the details, and he knows how the system is built. He knows a couple sub parts of the system around his system, but he doesn't see the whole picture. There is an enterprise level architect for that, but normally those don't know the details. So you have to kind of balance between those. Another very popular conflict in priorities. We want to develop the new features over the evaluating the system for the performance. Well, quite classical scenario. Overflow. And the conflict over the metrics and KPIs, where to place the measuring points, what to consider good results and what to consider bad results. Who's gonna interpret those results and explain to the business in the way that you should not worry, we evaluated the system against the 4 times of the load which we normally experience, and we didn't see any signs of degradation. We really do not, for next 20 years, if the things will develop in a linear way, you have nothing to worry about, really. So it sounds very simple, but it could be quite challenging in a larger organization. Regarding what kind of the profile the performance engineer has to have. Any of you planning to become a performance engineers? I will skip it. This one I will briefly touch. We spoke. You are familiar with the term continuous integration, continuous delivery.
They have to, at least.
Ah.
We had a lecture on DevOps.
Oh, yeah. Works quite well on the level of the team. And I really seen teams which incorporated the micro level performance tests and performance evaluation into their continuous integration pipeline. Remember when we spoke about that small cycle? Walked information in, magic, we measure the output. Scripts are written, incorporated into the continuous integration pipeline. The benchmarks are set. If we see the major degradation comparing to the previous run, the build is simply not getting assembled. The delivery doesn't move any further. More or less kind of simple stuff. When it comes down to the macro level, where we test the performance of the whole system, I don't see that fitting in anywhere. It's always custom exercise. It's always some special scripts have to be written just for that specific purpose. We're emulating the certain activities in a certain way, and totally different level. No, maybe in the future we will see some more modern tools which will help us to do those emulations on the fly and emulate those processes. Currently, no. And again, we are talking about the large systems, systems of the bank size. So currently, on the macro level, I don't see how the performance evaluation will fit into the classical CI/CD pipeline. The only couple things which I want to highlight in here, we have a separation of the macro level, the full system level, and the micro level. Here we're talking about the mock data, and here we're talking about scripts which are emulating the actual activity. And here we're talking about some virtual environment. And here, on the macro level, we're talking about something that is quite similarly set up to the production. Yeah. And here we're talking about involvement of the multiple teams, which are an integral part of the system. And here we're talking about team level. So quite a lot of differences, and that's why in this side, micro level, quite realistic to fit into the CI/CD, and just the way I explained. Not really, not at this time, not with the tools we currently have. All right, now, that's one of my favorite parts. Speaking about speaking about the environment. Remember, I've been stressing multiple times, and we identified that the performance evaluation is quite sensitive and quite dependent on the environment where it is hosted. Mhm. So how do we ensure that the environment against which we will be testing is set up as a production-like? Also, at the same time, if you will test with something, let's imagine you have several databases, and for the test purposes, your databases are not even filled 1-2%. The real databases will have tons and tons of records. Do you think the performance will be the same? Do you think that the techniques working with the databases will be used the same if you have 100 records or you have 100,000 records? No, it's just incomparable things. You really need to put your application into the environment which is as close to to something what you have in the production, then you might have some sort of results which you can trust, which you can correlate with the production numbers. Yeah. But again, if we're speaking about companies which own their hardware, we understand that it is quite expensive zoo of the metal pieces out there sitting in the server room. And we're talking not about the hardware being expensive by itself. We're talking about the licenses, which are ridiculously expensive. And if we're getting into the crypto side of it, cryptography, those licenses, man, they're horrible. I mean, they are expensive. To keep something for the test purposes set up exactly like your production with all those licenses costs and everything, luxury. Unlikely you will find yourself in a situation that any of the company will let you have the test environment just like your production. Just not lower your expectations. It's just not going to happen. Also, another quite important factor. Normally, you are emulating some sort of process which you want to test. You want to understand how fast the specific path will be taken. But at the same time, you need to understand that the system is not idling during that time, right? You are not the only one in the universe. You are not the only one process in the system which will get the priority over everybody else. Somehow you need to fake. Somehow you need to emulate the rest of the processes. You need to emulate that noise in the system. Okay, so that's just more scripts emulating the noise, and also the quality of the data emulation. Of course, you will be taking some shortcuts. Of course, you won't be able to, fake and emulate exactly the activity of 200 users. You will take some shortcuts here and there, but generally speaking, yeah. It will be looking like 200 users logged in almost simultaneously, did the most expected things what users will do, and you will be able to emulate and do the measurements. I will keep this one and we'll come back. After we will speak about performance evaluations in fraud. Is it really a blessing or it's a curse? Just several years ago, just for starting up the conversation that we will test something in fraud, no, probably you will be misunderstood, at least. Most likely it will cost you a career. Yeah? Especially if we are talking about some sort of sensitive customer information, which we will have in production. I know that larger companies like Google, they are using such thing as a segmenting, meaning they allocate in the part of the production environment for the test purposes. They let X amount of customers who maybe even consented to be used as a test customers or the beta customers. They are getting routed to that segment where the new build is deployed, and you are able to see, no, not the whole crowd. Let's imagine not the whole crowd heading towards the new service or improved service, which is deployed on the segment, or at least a portion. You will be able to understand what is the problematic areas out there. You will be able to take your measurements, and also it's set up in a way that if the things are going horribly wrong there, they will be routed automatically back to the main segment. Great system. I want to say I would like to have something similar in the bank, but we don't, due to the reasons. Thinking about pros for testing in production. No, you will get the real world environment. You will get the real users with real cases, things you cannot really even imagine that might have cost more. Yeah? Unforeseen issues, I guarantee you will have, and you will get a chance to identify them immediately. And you will get the user feedback. Absolutely. Absolutely agree with that. What are the possibilities out there? Prepare quick rollbacks. Let's imagine we're fairly confident in a certain fix, but the only way to test it is a prod environment. Huh? So what we are trying to do, or what we should be, let's imagine a hypothetical situation. Let's try to imagine the situation that we are confident enough to go with a fix, so-called blind fix, do the production and monitor the production environment, see how it's going to react. Now, first of all, you need to think about the backup. What you're going to do if things will go horribly wrong. How quick you can ship back. How quick you will be able to roll the things back and set up the stage for the safe environment. This part. The monitoring that comes together with the monitoring and alerting system. Of course, you set up your alerts on certain things, and you don't need physical people to sit in front of the monitors and look at the situation and monitor it in real time. You can have the alerting set up and monitor that. And this is just another term for the segment. That's what I explained in the beginning. When you allocate the segment where you apply where you apply the fix, you send the route the consented users towards that, and you look at the reaction. More or less clear. Another question which is very often being asked by the management during the budgeting time. As we already discussed, unlikely you will have the luxury of having your test environment set up in the same way as production. I can almost guarantee you, not going to happen. So during the budgeting sessions, when I make the requirements for the and requests for the test environment, I'm quite openly being asked, like, okay, why can't you just build 10 times weaker environment, exactly 10 times weaker? Keep the same absolutely component, but it will be 10 times weaker than our production, 10 times cheaper. That's time. Yeah? Simple extrapolation. This one is 10 times weaker, this one is 10 times quicker. Get your numbers here, multiply, you will get your numbers for the production, right? Simple enough. Who supports that logic?
Engineering.
Well, no.
Creating ship models, plane models, bridge models.
It doesn't quite work like that in the world of the hardware. And the previous diagram will explain why. Let me show you this. Yeah. So, I will very briefly go through that. So we do have three major parts in the how the hardware reacts to the load, and how do we measure? Let's imagine with this example, we are testing the A gap. Yep. In here, we do have a load. We are increasing the load. In here, we do have the response time. Okay, very simple, very simple. Blue line represents our strong environment, and this one is that cheap one, yeah? And 10 times weaker, 10 times smaller, as opposed to do the same thing, just with a factor 10. Simple math. No, not exactly like that. It's not that simple and not that straightforward with the first one. You can make some sort of assumptions how your stronger environment will react to the same load by the getting the numbers from the weaker one, but not always. I want to say most of the times you won't be able to. You simply will be guessing. And that's due to the fact that you have three phases. You're increasing the load. First of all, you're going to have that plateau effect, when the response time almost doesn't change. It fluctuates a little. And remember, when we're talking about the performance evaluation, we're always talking about the range. So you are sitting in that range of, let's imagine, between 4 milliseconds and 6 milliseconds. It fluctuates a little bit, but you really don't see anything going. Okay? Then you reach certain level, you reach certain load. Let's imagine that's 1,000 units right here. And you get into the so-called linear increase. This part is forecastable. It's linear. You apply more load, your response time is going to linearly increase. Simple like that. And then you're going to have the exponential increase part. Then all of a sudden it just skyrockets. You increase the load a little bit, and your response time goes up to the sky. Yeah? This part right here is the most problematic part. With that here, this is pretty much the main wall. You will get the denial of service. That's the place where the so-called response rate, response error increase. Meaning, in case of the simple API, the situation is going to be developing like this. That you will get the errors which are put back into the queue, the load doesn't decrease, so now you have to deal with the same load plus the queue, which error has been put in. You got into this turbulence area, pretty much start thinking how to smartly shut down your application. How not to end up in the middle of certain transactions, how to shut it down properly, how to give the denial of service in a proper manner, and how to restart your application. Okay. The essence of this example is that we have the blue line going through those 3 cycles. And we do have the red line, which represents a weaker, smaller model. Yeah? The thing is, that's, let's say, with a 300, that's not interesting. Let's say 600 users. Yeah? We are in the plateau area for the stronger environment, and we're already in the linear exponential increase time on the red line. You cannot correlate them like this unless you know those boundaries for the strong environment and for the weak environment. And we draw those lines like this. They're not, meaning there will be always some sort of fluctuation. Compare 10 times weaker environment to this to the stronger environment and try to forecast, extrapolate some sort of values. Almost impossible exercise. Just don't go for that. No, it's just not going to happen. It doesn't work like this. And this is a actually I was shown that picture to our management. They seem to get it. They seem to understand it. Okay, we spoke about that. Very briefly, we'll go through that. Probably this topic will not resonate. The tools. We've been speaking about. We've been speaking quite a lot about emulations. We've been speaking about quite a lot about how to automate certain activities. We don't want to bring 200 users in. We want to do something automated. So what are the big names on the market and what the categories are? Now, first of all, probably those load testing and stress testing tools. Anybody familiar with those? Anybody could shout some names? The big, huh? Enduro. Never used that. Maybe it is. Didn't really even know that it exists. No, there's certain tools for the database. They're quite separate batch. Probably the most known ones in here, in this area, will be your JMeter, Java-based. Quite good for emulating certain activities, emulating the requests from the user. Another popular one, and probably this one I would speak a little bit more about, is K6. Anybody heard of it? K6? No? TypeScript? What is so great about it? If I would be starting in this business right now, if I would know anything about it, I would definitely start with K6. Why it is so? It's quite well integrated with ChatGPT. Really, just simply given the proper request to ChatGPT, you will get quite adequate code which will be accepted by K6. So just remember that name. If you will get into the company, there is no performance evaluations out there, and they are about to start doing something in that direction. You are tasked to select the tool. That could be your, I want to say, that could be your choice number one, simply because the ramp up time with it is so quick. It's the code is so readable, and like I said, ChatGPT integrated perfectly into it. It's absolutely wonderful. All right. Skip through that. Probably not going to resonate here. No, and now we're getting to my favorite part. The part related to the bank and to the SEB. Before I will go to that slide, I would like to say that I normally spend 30 seconds of my lecture, really 30 seconds, to promote SEB really quick. So yes, we do have the collab programs with the Teltech. We do have quite a lot of students participating in our researches. This is the numbers you see on the screen. That's the numbers of the students, I think, over the period of 4 or 5 years while this program existed. I really do see students in our office, so that's quite realistic opportunity, and students are participating in our research labs. So this is quite an opportunity, quite something what you might want to consider, especially as we discussed the market situation at the moment and the stable employer versus the quick, how did you say that? Quick rewards, quick...
High risk,
high risk, high reward. Yeah, that's exactly the case. All right? Quite simple.